So on the previous video, we should have came to certain conclusions that if the a value is negative, it gets reflected on the x-axis, and you can see that here. The a value is negative, it got reflected. It's the same exact curve as this one up here, but it just got reflected on the x-axis. So every point is equidistant from the x-axis. So right here, 1 unit away would be down here. This one 2 units away would be down here. This one 3 units away would be down here. So it would get reflected perfectly on the x-axis if your a value changes to a negative. Not only that, we also went over this one, which had a outside value, the -2 on the outside. That really tells us that the original parent graph gets shifted down 2 units. So it used to be at the origin 0, 0. Now the beginning point is 2 units down. And that's no coincidence. Whatever this number is that you're adding or subtracting at the end, that's how it's going to make it shift up or down. Okay? Let's move on to this example right here. This one does not have a minus number or a plus number outside the square root. This one has a -1 on the inside of the square root. And that makes a huge difference, guys. Let's make an XY table, even though later on we're going to know that this is kind of a waste of time to make an XY table. Let's plug in some numbers that work. So would 0 work in this case? Yes, what's your question? So if I did plug in 0, think about that. If I plug in 0 right here, 0 minus 1 is -1, and the square root of -1 is I. So that's not a nice coordinate because you have imaginary numbers. No good. Okay, so what would be nice to plug in this case? 1 would be nice because 1, when you plug it in, 1 take away 1, 0, and the square root of 0 is 0. Okay? And what would be another number to plug in, a nice number to plug in? 2 would also be nice because when I plug in 2 right in there, 2 minus 1 is 1, and the square root of 1 is 1. What other number? 5 would be good because 5 minus 1 is 4, and the square root of 4 is 2. Which other number? 10 would also be good because 10 minus 1 is 9 and the square root of 9 is 3. So let's graph those coordinates. 1, 0, 2, 1, 5, 2. Okay, so I graphed the coordinate 1, 0. It's right there, 1, 0. 2, 1, 2, 1 is right there. 5, 2, and 10, 3. And if we connect those dots, we get that graph, and as we could see, if we were to compare it to the original parent graph, what's the difference between the original parent graph and this parent graph? Anybody? It moves where? 1 to the right. Okay, it moves 1 to the right. So, if the original parent graph moved 1 to the right, it has to come from this number, and we're eventually going to conclude that whatever you see here, you have to think opposite, right? So this -1 is really a +1 h shift, which we're going to talk about later. So I might as well tell you now, the h equals +1 in this case, and that's why it shifted 1 to the right. Now, if right here you would have had a +1, then it would have been 1 to the left, because you're always going to think opposite of what you see inside the square root. How about domain and range of this guy? So what would the domain be? Now remember, the domain are your x values, which here's your x-axis running left to right. Is there any part of this graph on the negatives on the x values? Yes or no? No, there's no part of the graph over here on the negative side. Okay? There's definitely on the positive side. So what would you say your domain is with regards to x, because your domain really are your x values, your input values? X is what?
Greater than or equal to 1.
Greater than or equal to 1. Perfect. Thank you, Athen. Greater than or equal to 1. Okay, how about the range values? Now the range values are your y values. So the y values are up here. 1, 2, 3, 4, 5, -1, -2. So are there any negative values on the y? No, there's positive values on the y, right? What are those positive values on the y? Or what would you say the range is? Y is what?
Greater than or equal to 0.
Greater than or equal to 0. Athen again. Okay, did anybody else get this besides Athen? Yeah, okay. Thank you. I mean, even if you were to look at the coordinates themselves, this coordinate was 1, 0. This coordinate was 2, 1. This one was 5, 2. Was it 5, 2? Yeah, I think so. And this one was 10, 9. No, 10, 9. 10, 3. After all, when we talk about domain and range, we are talking about the x and the y values. So as you can see, this x value is 1, this x value is 2, 5, 10, and the x values continue to grow. That's why the domain are x values that are greater than or equal to 1. The range are the y values, your y value of 0, 1, 2, 3. So it's obvious that your range y values start at 0 and it continue forever. So y is greater than or equal to 0. I hope that makes sense to you guys. We need to be able to do that this Friday's quiz. This next one has both an H and a K shift. So how about this? Instead of graphing with the XY table, even though it says using an XY table, how about we ignore the H and K shift and focus in on the parent graph, y equals the square root of x. Okay? Let's focus in on y equals the square root of x. And then we'll worry about the h value and the k value. As a matter of fact, since I already wrote it, what is the h value?
2.
It's actually -2, right? You got to think opposite. Yeah, there's a 2 in there, but when you think about the movement will be the opposite of what you see on h. How about the k value? It's actually the same exact thing, -3. Now, I guess maybe it should have been good to tell you about the notes down here. F of x equals a square root of x minus h plus k. Now, it says a is a vertical stretch of compression. We haven't even got to that yet. We'll get to that in a little while. H is your horizontal shift, but think opposite. So because there's a minus sign in front of the h on your form, you have to think opposite on h. So whatever you see there, you have to think opposite. Now the k, there's a plus k, you don't think opposite. K is your vertical shift. So if you see a plus 3 there, that means it's going to go up 3. If you see a minus 3 there, it's going to be going down 3. But the h is the left and right shift, and you have to think opposite on h. And I don't even know if you guys remember this, but this is your your vertex form quadratic function. Y equals a parentheses x minus h squared plus k. Do you guys remember that from parabolas? Yes, I remember that. Okay, that's good that you remember. When we did parabolas, the h and the k value were your vertex of your parabola. It was the most important point of the parabola, the h and k. And the h you thought opposite when you were trying to find the vertex of a parabola. So similar to the vertex form parabola, this new radical form to graph is graphed the same way. Down here, the most important point was your h and k, which gave you your vertex. Right here, your most important point also is your h and k, because that's where you start your graph. Okay? Let's go back up here to the one we're doing. And we already identified our h value being -2, our k value being -3. And what I'm going to do is ignore h and k for a little while. I want to forget about them, and I want to pretend that it just says y equals the square root of x. Because that's really easy to graph, y equals the square root of x. Once again, plug in 0, you get out of 0. Plug in 1, you get out of 1. Plug in 4, you get out of 2. Plug in 9, you get out of 3. Why? Because the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. Everybody understands the parent graph, right? Okay, so let's actually do a quick sketch of the parent graph. 0, 0, 1, 1, 4, 2, 9, 3. Okay? So 0, 0, 1, 1, 4, 2, and 9, 1, 2, 3. So there's my parent graph, but I'm not going to fully graph it because they don't want us to graph the parent graph. They want us to graph this new one that has a h that's -2 and a k that's -3. So what I'm going to do is I'm going to take these points and move them 2 to the left because my h value is -2 and 3 down. Once again, you think opposite on h. So because we had a 2 right here, you're going to go move it 2 to the left. Because you have a minus 3 here, you're moving 3 down. So let me take each of these points and map them, or the correct word is translate them 2 to the left and 3 down. So these points of my parent graph, I want to move them each 2 to the left and 1, 2, 3 down. I want to take the next one and go 2 to the left and 1, 2, 3 down. And this next one, 2 to the left and 1, 2, 3 down. And the last point, 2 to the left and 1, 2, 3 down. And you're actually on the x-axis. By the way, another way of doing it is once you identify your h and k, which is your beginning point, so this one goes 2 to the left and 3 down, you could also look at the pattern from here to here to here to here. So from here to here it goes up 1 over 1. So if you're at your beginning point, you could go up 1 over 1. And then the next one would be up 1 over 3, so you could go up 1 over 3. Just depends how you like to graph. Shifting all of your points, 2 to the left and 3 down, 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 or using the pattern that you see on your apparent square root function, which is up 1 over 1, and then up 1 over 3, and then up 1 over 1, 2, 3, 4, 5. Does that make sense? Okay, so this is our actual graph with the beginning point right there. And what the heck is that coordinate? That beginning point. -2, -3. So it's important to identify that HK value because that makes the domain and range easy to state. What is your domain in this case? X is what? Greater than or equal to, whoa, that's less than or equal to, greater than or equal to -2. Now once again, we know it's greater than or equal to because this whole graph is above this line, the y, or greater than this line, which is x is -2. Okay, it's going to the right, so it's greater than or equal to -2. Now, with regards to the y values, the range, y is what? It's also greater than or equal to because it's going up, right? Y is greater than or equal to what? -3. So that's the domain and range.